In this video, we are going over the Math 1 Practice EOC problems 36 through 40. For number 36, it says Lucy and Barbara began saving money the same week. The table below shows the models for the amount of money Lucy and Barbara had saved after X weeks. After how many weeks will Lucy and Barbara have the same amount of money saved? Okay, so if you're not recognizing right away, this is definitely a systems problem. This could honestly be an 8th grade math problem because they're giving you the two equations. You can graph them on your calculator and see when they intersect. You can use graph paper and graph them, or you can solve them algebraically by setting them equal to each other. Because I want to know when the costs are the same. So, doesn't matter which one you put on which side. I'm going to solve for x. So I'm going to subtract 7.5x, both sides. Bring this down. That's going to give me 2.5x plus 5 equals 25. Okay? Well, then I need to get x by itself. I'm going to subtract 5 from both sides. That gives me 2.5x equals 20. Okay, I want to get x by itself, so I'm going to divide both sides by 2.5. And x equals 8. Okay, for 37, this is a domain and range problem. Colin noticed that various combinations of nickels and dimes could add up to 65 cents. Let x represent the number of nickels and y for a number of dimes. So x is nickels and y is going to be my dimes. Okay? But what is the domain? Domain where y is a function of x and the total value is 65 cents. Domain represents your what? X's. Okay? Domain and range is just like x comma y. This represents my x values, this represents my y values. So when I'm talking about x's, I'm really talking about what? Nickels. What are my combinations of nickels I could have that would make up 65 cents? Well, I can go ahead and rule out these, because if I have 6 nickels, or if I have an even number of nickels, that's not going to leave me with a 5 at the end. Okay? So these two are out because they're even. Can't be even. The last two are odd, except the only difference between them is that C includes 0. If you have 0 nickels, can you make 65 cents? No. So it has to be C. I have to have an odd number of nickels to be able to combine with dimes to make 65 cents. Okay, for 38, we did not go over these specifically, so if you got this one wrong, definitely do not be upset with yourself. It's kind of a strange standard, and there's probably only going to be 1 or 2 of them on, mainly one of these on the EOC. I'm going to show you 2 different ways to do it. This was not something that people taught me when I was in school, so that's why it's kind of new. I don't even necessarily know what it's called. This is obviously an exponential function, but this is different. Okay, so 2 different ways that you could go about this. I'm going to go the long way first. Okay, so what's the value of the value of an antique car is modeled by this exponential function. X is the number of years since 2005. By what approximate percent rate is the value of the car increasing per year? Okay, so well, what I did was I plugged this into my Y1, and then I went to the table function, and I recorded the first several values. So I put it into the calculator, went to the table, and then just started writing them down. So it starts at 107,000. After 1 year, it's at 107,641. That's at 108,286. And then the 3rd year is 108,935. Then I said, okay, well, I'm going to try to figure out how much it's going up by. So I used my calculator and I subtracted. And this went up 641. From here to here, it went up 645. From here to here, it went up 649. Now, obviously, I'm not expecting it to go up the same amount because it's exponential. Okay? And then I said, okay, well, if they're asking me for the percent that it's increasing, I figured out, well, I could make a fraction. This is how much it went up from what it started from. So I said, okay, well, if I take 641 and I divide it by 107, I get 0.0059. That's pretty close to one of my equations. Okay, well, let me try another one. If I take 645 and I divide it by what it was coming from, which is 107,641, I keep getting the same thing. So let me try the last one. If I take 649 and I divide it by the one behind it, or the one it's changing into, sorry. 108, 9, 1 behind it. So 108, 286, okay? I should get the same thing. And then I realized, well, this is a fraction. I need to turn it into a percent. Okay. And this obviously goes on 9, 7. Okay, so I said, well, based on this, I'm pretty sure I'm going to rule out these, because you've had ones before, so I'm pretty sure it's going to be C. But just in case, if this, how do I turn this into 0059? How do I turn it into a percent? I move the decimal what? 2 places, okay? And that gives me 0.59%, which is really close to C. Okay. So that's how I solved this the very first time, because I'd never seen this before, and I just used common sense with my answer choices and some reasoning to figure this out. Now, the next part I can tell you, I just got to remember how to do it on the EOC if you don't use reasoning. To figure out this, you can also take what's inside, okay, and I turned it into a percent. I said 0.9, and I times it by 2/3, and it gave me 0.6. And when you do 2/3, you got to use parentheses, okay? And I did that because I moved it 2 places over because I turned it into a percent. Okay? So if you do that, it should work. But if you're like, why does it work? Then I would use the reasoning that I have here. Okay, for 39, the table below shows the cost of pizza based on the number of toppings. Which function represents the cost of pizza within toppings? Okay. Well, the first thing I'm noticing is that how much does it cost per topping? $1.50. Every time I go up on this side, bottom one, I add $1.50. Okay. And I know that my y-intercept is when x is what? 0. So if I go back one, what number when I add $1.50 is going to give me $12? $10.50. All right. So I've got all that, so that's good to know. Now I know n represents the number of toppings. So the other thing I know is that I should be able to plug these values in for n in these equations, and it should pop out this amount of price. If it doesn't, that's not the answer choice. Okay? So for D, if I plug in 1, I get 12. That's right. If I plug in 2, I get 24. That's not right. That means D's out. Okay, for C, if I plug in 1, I get 12 plus 1, which is 13, which is not correct. When I plug in 1, I should get what? $12. That's out. Doesn't make sense. Then I plug in 1 here. Okay, so 150 times 1 plus 12. Well, that's going to give me 1350. When you plug in 1, you got to get what? 12. So that doesn't work. Let's see what happens here. 12 plus 1.5 times 1 minus 1. What's 1 minus 1? 0. What's 150 times 0? 0. And I get 12. My answer is A. Alright, for 40, this one is also very extensive. I had a lot of work. You might have a faster way to do it, but I'm just going to show you the way I did it. Also, Paul sells chocolate chip cookies and peanut butter cookies. Baking a batch of chocolate chip cookies takes 1.75 cups of flour and 2 eggs. Baking a batch of peanut butter cookies takes 1.25 cups of flour and 1 egg. Paul has 10 cups of flour and 12 eggs. He makes a $4 profit per batch of chocolate chip cookies, and he makes a $2 profit per batch of peanut butter cookies. How many batches of peanut butter cookies should Paul make to maximize his profit? Okay, if I want to make the maximum profit, I want to sell more of the thing I make more profit on, which is what? Chocolate chip cookies. I want to sell as many chocolate chip cookies as I can to make the most profit. There's a lot to keep up with because each set of cookies has two different totals going on. So what I did was I made a table, which is located here. This might look confusing at first, but it's really not. This shaded region represents the chocolate chip cookie side. This represents the peanut butter. The one thing that is helpful about this problem is that it's not grid response. These are my only options. How many batches of peanut butter cookies? 1, 2, 5, and 8. Those are the only ones I'm going to plug in. So when it says number of batches for chocolate chip cookies, I'm going to put in 1, 2, 5. Let me add a row here. Okay, so 1, 2, 5, and 8. From there, I'm going to plug in what I know. If I make one batch of peanut butter cookies, it's going to take 1 egg. It takes 1.2 cups of flour, and I'm going to make $2. Okay? I know that if I make 2 batches, that's going to use 2.5 cups of flour. It's going to take me 2 eggs, and I make $4 just off the peanut butter. For 5, it's going to take 6.25 cups of flour, 5 eggs, and I make $10. And for 8, it's going to take 10 cups of flour, 8 eggs, and I'm going to make $16. Okay. Now that I have this information, I can fill in this side because I only have a total of what? Okay. You have a total of 10 cups of flour and 12 eggs. Can't go over that. So what I did on this side was, how many batches? So I said, well, if you have 12 eggs, you take 1 out to make peanut butter, that leaves 11. But it takes 2 eggs to make a batch of chocolate chip cookies. So that means I'm only going to be able to make 5 and use 10 eggs. And I said, if each flour is 175, and I'll put that here, okay? And it takes 1 egg per person and 2 eggs to make each batch. That might be helpful, okay? And these are $4 a piece, and these are $2 a piece, okay? So 5 times 175, you get 8.75. And if I'm making 5 batches of cookies and they're $4 each, that's $20. So now when I want to know my total money from this combination, it's $22. Okay, well now if I use 2 batches of peanut butter cookies, that's 2 eggs. That leaves me 10 eggs left over. Okay, but for flour, it's going to take up 250. Well, 10 minus 250, and you get 750. Well, I need, if I divide that by 175, I get 4.28, which means I'm only going to be able to make 4 batches of these. Okay? That's going to use 8 eggs, 4 times 175 is 7, and 4 at $4 each is $16. Well, now if I take $16 and add to $4, I get 20. Well, I can already tell this number is only going to do what? Get smaller, right? Because this is the maximum number of chocolate chip cookies I can sell and still have leftover stuff, and they're $4 a piece. So I already know that I only need to make 1 batch of peanut butter. And that's the end.